Hello viewers, I am Kausalya. Today we are going to solve problems related with magnetic coupled circuit. So here the problem is determine the phasor currents I1 and I2. So here this is a given problem. Our problem has two loops and I1 is the current that flows through loop 1 and I2 is the current that flows through loop 2. And here you see J3 is the mutual inductance that exists between these two reactances. So because of this mutual inductance, there will be a mutual voltage at this point, that is after this inductor as well as at this point, right? So here the first step is we will write the value of the mutual voltage. So it is clear, right? What is the current that flows through this inductor? It is the current I1, right? And here when you look at this inductor, what is the current that flows through this? Here this inductor is common for loop L1 and loop L2. And again look at the direction of the current. I1 flows like this whereas I2 flows in the opposite way. Right. Therefore the current that flows through this J6 reactance is I1 minus I2. Right. So this is our first thing. Then the next thing is we are going to write the mutual voltages. That is, because of the current flowing through this inductor, there is a voltage available at this inductor, right? And vice versa. So first I'll write the value of the mutual voltage at this inductor, right? So here the value of this mutual inductance, it is J3, right? And this is because the current flowing through this J6 reactance. Therefore, here the current flowing is I1 minus I2, right? Now, again, look at this part, right? Here there will be a mutual voltage because of the current flowing through this J2 reactance. So, here the value of this mutual voltage is, it is J3, right, multiplied by what is the current that flows through this reactance? It is I1. So here it is J3 I1, right? So first write down the values, then we will assign the sign. So here you see that is through this J2 reactor, okay, J2 reactor, here I1, that is it enters the inductor at the dotted terminal. Whereas in J6 reactance, the current leaves the terminal at the dotted point, right? So they are opposite to each other, right? Here the current enters at the dotted point, here the current leaves at the dotted point. Therefore, here we are including a minus sign for both these voltages, right? So here again I am trying to tell, I am not going logically. I am just telling you the simplest way to solve this problem, right? So here after writing the values along with their respective signs, then apply KVL. So when you apply KVL to this loop, what happens? Sum of voltage drop in a circuit is equal to sum of voltage rise, right? So here in this case, what are all the respective voltage drops? You see 5 into I1 and here J2 into I1 and here J6 into I1 minus I2. First write down the respective voltage drops for each and every element which is present there, right? And then now we are going to write the mutual voltage drops. So here the value of this mutual voltage drop is minus J3 I1 minus I2. So here I have written, and here it is again minus J3 I1, right? So these are all the respective voltage drops in your loop 1. So here which is equal to what is the value of voltage rise? That is here the source voltage is 100 with an angle of 60 degrees. So write it as 100 with an angle 60 degree, right? So this is your first step here, right? Then the next thing is we have to multiply and solve. So just multiply the terms, right, and combine the I1 terms together and I2 terms together. So when you do that, here we are ending up with the equation like this, right? So here I have converted this polar value into rectangular form. That's it, right? Now we are going to apply KVL to our loop 2, right? So when you apply KVL, so I2 is the current that flows through the loop 2, right? So therefore minus J4 into I2 right? And again plus J6 into, now we are considering our second loop. So we have to write it as plus J6 I2 minus I1, right? Then apart from this, we are having some mutual voltage, right? So here the mutual voltage is, you see, this is opposite to the direction of the previous thing, right? Therefore, or in other words, you can say, when considering the first loop, the current leaves at the daughter terminal. But when you consider the second loop, the current enters through the daughter terminal, right? So here we have to write this value of mutual voltage as plus J3I1, right? So this is your equation, right? Now again, as usual, just multiply the terms, right? So just multiply it, and again we are going to combine I1 and I2 terms together. So when you combine I1 and I2, you see finally we are ending up with an equation like this. Minus 3j I1 plus J2 into I2, which is equal to 0, because in our second loop there is no source voltage, right? Our second loop has only one inductor and a capacitor, right? So now we are having our two equations, right? This is your equation 1 and this is your equation 2. Now we are going to solve. So this is your equation 1 and 2. So just write down it in the matrix form. So here we are in need to find the values of I1 and I2. So first calculate the value of del. Del is nothing but the determinant part of this matrix, right? So here just as usual multiply and finally get the answer, right? 5 plus 2j into 2j minus of minus 3j the whole square, right? You can simply solve using a calculator, right? No need of manual calculations here. So here the answer is 10j plus 5. Now the next thing is we have to calculate del 1, right? So for calculating del 1, we have to replace this first column with this source voltage. So here I had directly written in rectangular form since the other terms are in rectangular form, right? So just multiply. When you multiply and solve, here we are getting the answer as 199.99 with an angle of 149.99, right? Here if you wish, you can round it off as 200 with an angle 150. Okay, it is also right. Now the next thing is we are finding del 2. So how to find del 2? You have to replace this, right? You have to replace this second column with this voltage source. So once you replace this and solve, here you see this is your value of del 2, right? 299.993 with an angle 149.99. Again here you can round it off to 300 with an angle 150, right? So here now just substitute the values, right? Del 1 by del. So just substitute the values and solve. Okay, either you can have in the rectangular form or you can have in the polar form. Okay, either way is correct. So here the answer is 17.88 with an angle of 86.56 amps. And the next thing is I2. Here I2 is given as del 2 by del. So again just substitute the values here, and here the final answer is 26.83 with an angle of 86.56 amps. Right. So here comes the end of this problem. I believe you people just understood this. If you have any doubt, let me know in the comment section. Thank you.